parameters of the system curve: kinetic head, pressure head, and elevation. However, the problem with Bernoulli's equation is that it does not consider energy loss. And since there is energy loss, one parameter that needs to be considered is friction loss. You still with me? Great. Now, friction loss is made up of two parts: major loss and minor loss. And the major loss can be resolved by using the Darcy's equation. Using a variation of Darcy's equation, you can see the formula for major loss. However, there's a particular value of Fd, which is Darcy's friction factor. The top three methods of working out Darcy's friction factor are Colbert-White, Moody diagram, or Swaney-Jane equation. However, despite what method you use, each equation requires you to know Reynolds numbers. Technically speaking, the Reynolds number is a ratio of inertial forces and viscous forces. In practice, the Reynolds number is used to predict if the flow will be laminar or turbulent. In most situations, the flow rate is turbulent, hence why we use one of three methods shown in the previous slide. The minor loss is a product of the velocity head. Simply put, for each bend, taper, T, valve, etc., there's a K value. The K value comes from rigorous testing and experiments, which over decades have proven its accuracy in live installations. And these values are used to work out the pressure loss within the connection. Okay, so the question is, how do we wrap all this up to make sense? Well, it's like this. The major loss plus the minor loss can be rearranged to form one equation. Since the velocity is the same within a fixed pipe section, we can dismiss this value. And to convert pressure in pascals to pressure in meters, you can divide by the density in gravity. So to summarize the change in pressure, you end up with this formula. Thankfully, it's very rare that you will come across a situation where you need to understand first principles to be able to put together a system curve. There's numerous tools, softwares and spreadsheets out there to help you with the vast majority of applications. And for domestic uses, there's rule of thumb guidelines to help you calculate the requirements per utility.